Open source. In this video, we are going to see about open source. Open source software is software whose source code is available for modification or enhancement by anyone. Source code is a part of a software that most computer users don't ever see. It's the code computer programmers can manipulate to change how a piece of software, a program or application works. Programmers who have access to a computer program's source code can improve that program by adding features to it or fixing parts that don't always work correctly. The term open source refers to something that can be modified and shared because its design is publicly accessible. In general, open source refers to any program whose source code is made available for use or modification as users or other developers see fit. Open source software is usually developed as a public collaboration and made freely available. Open source is a certification mark owned by the Open Source Initiative, that is OSI. Developers of software that is intended to be freely shared and possibly improved and redistributed by others can use the open source trademark if their distribution terms conform to the OSI's open source definition. To summarize, the definition model of distribution terms require that the software being distributed must be redistributed to anyone else without any restriction. The source code must be made available so that the receiving party will be able to improve or modify it. The license can require improved versions of the software to carry a different name or version from the original software. Users. Open source software is software developed by and for the user community. Discover the wide variety of open source applications, from productivity applications to calendaring or email software, and learn more about the benefits of personal use. Developer. Open source projects provide tremendous opportunities for developers to share and learn through collaboration. Find colleagues for your project or join an existing effort. Contributions aren't limited to code. Successful open source projects need a diverse range of skills. Advantages: cheaper than commercially marketed products, created by skillful and talented people, highly reliable, help you become more flexible. Disadvantage: vulnerable to malicious users, might not be as user-friendly as commercial versions. don't come with extensive support. Linux origin. In this video, we are going to see about Linux origin. The last 1960s and early 1970s were the dawn of the modern computing era. It was the period of proprietary stacks, where a vendor would build a closed computer system and create the operating software to run on it. Computers were extremely expensive and rare among businesses. In that period, scientists were still looking for the best way to operate a computer, and that included developing the best programming languages. It was normal for computer programmers to address the hardware directly using very complex assembly programming languages. An important step forward was the development of the general-purpose programming language C by Dennis Ritchie at Bell Telephone Laboratories in 1969. This language was developed for the use with the Unix operating system. The Unix operating system was the first operating system where people from different companies tried to work together to build instead of competing with each other, keeping their efforts secret. This spirit brought Unix to scientific, government, and higher education institutions. That it also became the basis for the rise of another phenomenon, the Internet Protocol, that is IP, and the Internet. One of the huge contributors to the success of Unix was the spirit of openness of the operating system. Everyone could contribute to it, and the specifications were freely available to anyone. Because of the huge success of Unix, companies started claiming parts of this operating system in the 1970s. They succeeded fairly well, and that was the beginning of the development of different flavors of Unix, such as BSD, Sun Solaris, and HPAIX. Instead of working together, these Unix flavors worked beside one another, with each sponsoring organization trying to develop the best version for a specific solution. As a reaction to the closing of Unix, Richard Stallman of MIT announced in 1984 the GNU Operating System project. The goal of this project was to develop a sufficient body of free software to get along without any software that is not free. During the 1980s, many common Unix commands, tools, and applications were developed until, in 1991, the last gap was filled in with the launch of the Linux kernel by a student at the University of Helsinki in Finland, Linus Torvalds. The interesting fact about the Linux kernel is that it was never developed to be part of GNU project. Rather, it was an independent initiative. Torvalds just needed a license to ensure that the Linux kernel would be free software forever, and he chose to use the GNU General Public License, that is GPL, for this purpose. The GPL is a copyleft license, which means that derived works can be distributed only under the same license terms. Using GPL made it possible to publish open source software where others could freely add to or modify lines of code. Torvalds also made an announcement on Usenet, a very popular news network that was used to communicate information about certain projects in the early 1990s. In his Usenet message, Torvalds asked others to join him working on the Linux kernel, a challenge that was very soon taken up by many programmers around the world. Red Hat distributions. In this video, we are going to see about Red Hat distributions. Red Hat formerly provided a single series of Linux distribution known as Red Hat Linux. Red Hat Linux included distinct offerings for various, but the offerings were all based on one stable core. Now, Red Hat provides several Linux distributions, and it's worth understanding the strengths and weakness of each. At the same time, remember that the distributions all include essentially the same software. Red Hat came to recognize that its distribution interests two very different types of people. One type is business clients who want stable software that comes with support and are willing to pay significant money for that support. If the software changes slowly, that is fine with such users because it means fewer wrinkles and less time spent on upgrades. The other type of people who used Red Hat love to experiment and make use of the newest, most advanced features of Linux. These people don't mind upgrading frequently, but they are not running mission-critical systems and don't want to pay for support. In fact, they are used to getting Linux at no cost. Red Hat decided that by offering multiple distributions, it could make both types of users happy and get revenue from its efforts while benefiting from the testing and experimentation of the user community. Thus, any software that bears the trademark Red Hat is licensed software. It is backed by Red Hat in some manner, often through support contracts that include upgrades. It is expected to change only once every 2 or 3 years. By contract, the freely downloadable version of the distribution is called Fedora Core or simply Fedora. Fedora comes without Red Hat support. New versions of Fedora are released every few months and contain a lot of new features. Despite the outward similarity between Red Hat Enterprise Linux and Fedora Core, these distributions reflect divergent goals and methods. The Fedora Core team promises 2 to 3 releases per year of their distribution, a rapid development pace that will enable them to incorporate the most recent available versions of Linux software in a timely manner. However, Fedora Core's rapid release cycle does not afford opportunity to perform quality assurance appropriate for enterprise environments where reliability and security are crucial. Moreover, updates to a given release of Fedora Core are promised to be available only until 2 to 3 months after a subsequent release. Thus, users of Fedora Core can expect to have to install a new release of Fedora Core every 6 to 9 months or leave their systems vulnerably to security flaws for which updates are not available. Consequently, Fedora Core is best suited for use by hobbyists and others interested in sampling the bleeding edge of Linux technology and features. Linux principles. In this video, we are going to see about Linux principles. Linux is one of popular version of Unix operating system. It is open source as its source code is freely available. Linux was designed considering Unix compatibility. Components of Linux system. Linux operating system has primarily 3 components: kernel, system library, system utility. Kernel is a core part of Linux. It is responsible for all major activities of this operating system. It consists of various modules and it interacts directly with the underlying hardware. Kernel provides the required abstraction to hide low-level hardware details to system or application programs. System library. System libraries are special functions or programs using which application programs or system utilities accesses kernel's features. These libraries implements most of the functionalities of the operating system and do not require kernel modules code access rights. System utility. System utility programs are responsible to do specialized individual level tasks. Kernel mode versus user mode. Kernel component code executes in a special privileged mode called kernel mode with full access to all resources of the computer. This code represents a single process, executes in single address space, and do not require any context switch and hence is very efficient and fast. Kernel runs each processes and provides system services to processes, provides protected access to hardware to processes. Support code which is not required to run in kernel mode is in system library. User programs and other system programs works in user mode which has no access to system hardwares and kernel code. User programs or utilities use system libraries to access kernel functions to get systems low-level tasks. Basic features. Following are some of the important features of Linux operating system. Portable, open source, multi-user, multi-programming. Portability means software can work on different types of hardware in same way. Linux kernel and application programs support their installation on any kind of hardware platform. Open source. Linux source code is freely available and is community-based development project. Multiple team works in collaboration to enhance the capability of Linux operating system, and it is continuously evolving. Multi-user. Linux is a multi-user system, means multiple users can access system resources like memory, RAM, application programs at same time. Multi-programming. Linux is a multi-programming system, means multiple applications can run at same time. Hierarchical file system. Linux provides a standard file structure in which system files or user files are arranged. Shell. Linux provides a special interpreter program which can be used to execute commands of the operating system. It can be used to do various types of operations, call application programs, etc. Security. Linux provides user security using authentication features like password protection or controlled access to specific files or encryption of data. Architecture. Linux system architecture consists of the following layers. Hardware layer. Hardware consists of all peripheral devices, that is RAM, HDD, CPU, etc. Kernel. Core component of operating system interacts directly with hardware and provides low-level services to upper layer components. Shell. An interface to kernel, hiding complexity of kernel's functions from users, takes commands from user and executes kernel's functions. Utilities. Utility programs giving user most of the functionalities of an operating systems.